Hello, hello, hello. We're back again. Nice sunny day out there, thus the shades. I have them on to tell you that this isn't a promise, but I'm going to try. If we have a cloudy, wet, cold day out, those are the days I'm going to give you the work that takes a little longer. But if we have a nice sunshiny day like today, I'm going to try really, really hard to follow the weather. And if I know it's going to be a super nice day out there, I'll give you a very light workload when I can. Again, not a promise, but I'm going to try. And I'm hoping that if I am respectful of that for you, you will get your work in on time so you don't lose any points. Okay? So we're going to move on to square roots only. Now we're going to add variables into the mix. And so it's basically what we've been doing, only now we've got variables as well. So our formula is basically a to the m, and there's nothing in the index, which means it's assumed to be a 2. Okay? So it will resolve as a to the m divided by 2. All right? Well, let's just see if that makes sense. So the square root of x squared is like saying the square root of x times x. And I told some of you when we were on Google Meets, this is kind of like the house. And remember when you were little, your mom said you can only go outside if you go with a friend? All right. So you can't go by yourself. So you had to have somebody join you. So 2 had to be together to leave the house. And that resolves as x times x. There's 2 of them. So for every 2 inside the bracket, I can pull 1 out. All right? Let's see if this formula does the same thing. So, a to the m divided by 2. Well, my a is x to the 2 divided by 2. 2 divided by 2 is 1. That leaves me x to the first power, or simply just x. So our rule works. You'd probably like it better if I called it a. So just to make you happy, I'll call it a so you can see it exactly. So a to the m is like saying a to the m, which is 2, divided by 2, which is a to the 1, or simply a. All right, so that's pretty much all we're doing here. Let me give you another one, only maybe this time it would be the square root of, say, 16 times x to the 4th. All right, well, I'll take the square root of 16 first. So the square root of 16 is what number times itself gives you 16, and we know that answer is 4. And then how many x's? Well, I say x to the m, which is my 4, divided by 2, or 4x squared. See? M divided by 2. My m is 4 divided by 2. Let me show it to you this way. Whichever way you like better. I can say that this is like saying 4 times x times x times x times x. And since this is a 2 in the index, because it's not spoken, so we know it's a 2. For every 2 that are the same, I can pull out 1. 4x squared. Whichever way you like it. Now, every once in a while, you're going to come up with a number that doesn't work out evenly. So what are we going to do in those cases? So what if I have like, my name's Kelly, so we'll do k to the 5th. Alrighty, so that's like saying k to the 5 divided by 2. Well, 2 goes into 5 2 times with 1 left over. 2 goes into 5 2 times with 1 left over. Let me show it to you with the other technique. So, k to the 5th is like saying k times k times k times k times k. All inside our radical. All right, remember, it's square, so you need, for every 2 you have inside the radical, you can pull out 1. There's 1, there's 2, and there's 1 still left inside the radical. So, whichever way you like to look at it is fine, just so you come up with k squared and leave the other in the square root bracket. Let's look at this one. 121r cubed. And there's no index, so we know it's a square root. I know that the square root of 121, or what number times itself gives you 121, and I know that that is 11. R to the 3 divided by 2. That would give me 11. R, 2 goes into 3 one time. 1, but I don't have to write that, I can just assume. And there's 1 left over. Let me show it to you this way. It's like saying the square root of 11 times r times r times r. All right? For every 2, 1, 2, you can pull out 1. 1, 2, I can pull out 1. This fella's still left inside our radical. Okay? And they can get bigger. They can get bigger. They can have multiple variables. It's all good. 64, the square root of 64 is 8. Square root of r squared is r. The square root of s cubed. Well, that is going to let me pull out 1, but it is going to still leave 1 inside the radical. Okay? And then t to the 6 divided by 2 is t to the 3rd. And that's what you would have. Let me show it to you the other way. The square root of 8 times 8 times r times r times s times s times s times 1, 2, 3, 4, 5, 6 t's. Okay? Here is 1 pair, so I can pull out an 8. Here's a pair, I can pull out an r. Here's a pair, I can pull out an s. Here's a pair, there's 1t, 2t, 3 t's I can pull out, and I still have a single s, so it stays inside the radical. Hope this is nice and easy for you. Take it easy. Get your work done. You're doing great. Keep it up. We don't have that much longer. Take care, guys.